mixed numbers. Start out with your joke. What do you call a pretty angle? Well, of course, it's a cute angle. All right, warming up our brains. Name the common denominator for the following. What do halves and thirds have in common? It's 6. What do fifths and thirds have in common? 15ths. What do 4 and eighths have in common? Eighths. What do fifth and eighths have in common? 40ths. All right, now a little bit more tricky because we're going to have 3 different fractions. What about halves, thirds, and fourths? If you said 12ths, you are correct. Halves, fifths, and sixths, 30ths. Now remember, to find a common denominator, a way to find a quick common denominator is just to multiply the denominator. So in this case, 2 and 3 would be 6. 5 and 3 is 15. This is a little different because 4's already go into eighths, so that's why we're going to keep it with the eighths. 5 and 8, 5 times 8 is 40. 2, 3, and 4, getting to 12. And then taking a look at just 5 and 6, which is 30, and we know that 2 goes into any even number. Knowing your common denominators is going to be very important once again as you are subtracting fractions. Remember, you always need to have a common denominator when adding or subtracting fractions. And that is going to be the very first part that you are going to do. So if we're going to go ahead and get started with 3 1/3 and we're taking away 1 2/3, some of you probably could do this one in your head, but we're going to go ahead and step through the actual process of doing it. Well, first we have to see that do we have a common denominator? We have thirds and thirds, so we do. So we can go ahead and do the next part. But can I take 2 away from, or 1, can I take 1 minus 2? We cannot do that. We have a bigger bottom. And just like when we are subtracting regular whole numbers, bigger bottom we have to borrow. And that is going to be the case here as well. So we are going to go ahead and borrow from our whole number. And we're going to make it 1 less, just like we always do when we are subtracting whole numbers. But now we've got to bring over, we have to carry over that whole over here. So before in regular subtraction we just bring a 1, but we need to actually bring a whole. And if we're taking a look, we're using thirds. So what is 1 whole equal to when we're talking about thirds? Well, of course, that's 3/3. Now, we're not just going to take 3/3, but because we're adding 3/3 onto the 1/3 that was already there, so now we have 4/3. Now we can take our new fraction of 4/3 and take 2/3 away. Denominator stays the same. And 4 minus 2 is going to be 2. Once we do our fraction part, then we can go ahead and move to the whole number. So we have 2 minus 1, which is 1. So 3 1/3, and we're subtracting 1 2/3 would equal 1 2/3. Taking a look at another example. First, check to make sure that we have a common denominator. In this case, we have thirds and halves. Are they common? No. So let's find a common denominator. I know that a quick common denominator would be 6. 3 times 2 is 6. I'm going to go ahead and get equivalent fractions into 6. How did I go from 3 to 6? Well, I multiplied it by 2. If I do it to the top or bottom, I need to do it to the top. 1 times 2 is 2. How did I go from 2 to 6? I multiplied by 3. If you do it to the denominator, you need to do it to the numerator. Once again, if you take a look at this example, we have a bigger bottom. 3 is bigger than 2. I can't take that away, so I have to borrow making it a 2, and bringing over what? What is equal to 1 whole? We're taking 1 whole away here. So what is that going to be? Well, 6 in this case, because that is the current common denominator. Alright, so adding our fraction, 2 6 plus 6 6 is 8 6. Now, a very common mistake that I often find 5th graders doing here is they try to reduce this, and we don't want to reduce this down because then we'd be just getting back to where we started out. So yes, it's going to be improper, it could be reduced, but we don't want to reduce it until the very end when we have finalized all of our work down here. All right, now we have 8 6 as our new fraction after we've borrowed and made equivalent fractions. So now we're going to do 8 minus 3, which is 5. Our denominator is going to stay the same. And now we can subtract our whole number, 2 minus 1, which is 1 and 5, 6. All right, if we had 3 1/3, we know that that can also be equal to 1 7/3 as well. The picture kind of shows that. The reason why this is in here is because we need to know that 1 whole can also look like 3/3. And so that might help us when we need to subtract. Taking a look down below, I have a couple examples that I would like you to try. I will describe the first 3 for you, and if you would like to pause the video so you could get started. Alright, taking a look at the first example here, I have 8 minus 3 2/3. Sorry about that, 2. Okay. Right now, we have no fraction that we are subtracting. So we need to borrow from the 8 so we can take away from here. And remember, we already have a denominator of 3, so we might as well continue that. And how many thirds is equal to a whole? 3/3 is. So now 3/3 minus 2/3, we are left with 1/3. After you subtract your fractions, you need to subtract your whole number. 7 minus 3 is 4. So there you go. 7 3/3, they're taking a look at making all of the wholes into thirds, which is a little bit more difficult of an idea. So I would just go ahead and continue doing the way I just have shown. All right, looking at our next example, 6 minus 1/4. If you noticed how I set this problem up, I put, just like if we were lining up, adding and subtracting with hundreds, would be lined up with hundreds, and tenths or with tenths. I want to do that same idea of doing fractions with fractions and whole numbers with whole numbers. There's no there's no fractional piece here. There's no whole number here. All right, to get started, I have no fraction to take away from, so I'm going to borrow. And what is equal to a whole? Well, our denominator is fourths, so 4/4. All right, we can subtract 4/4 and 1/4. 4 minus 1 is 3. Denominator stays the same. Subtract whole number. 5 minus nothing is 5. So 5 3/4 should be our answer. Make sure you're reviewing the steps. If you miss something, you're finding the mistake that you have made. One last example that I'm going to step you through is 4. Hoping you can't see that. Sorry. Four 3/5 minus the 1 4/5. If we take a look, we already have a common denominator, so we don't need to do any equivalent fractions. But I have a bigger bottom, so I need to borrow, making this one less, so 3. I'm going to be bringing over 5/5 to the already 3/5 that was there, so now I have a total of 8/5. Remember, no reducing down here. Now I should be able to take 8 minus 4, which is 4. Denominator of 5 stays the same. Now we can subtract whole numbers. 3 minus 1 is 2. So an answer of 2 4/5. Looking at 5 1/6 and 2 5/6, they have a common denominator, but bigger bottom, so we needed to borrow, bringing over 6/6 to make it 7/6. So we should have had an answer of 2 1/3. Next problem, they both have a common denominator, but once again, we have a bigger bottom that we are subtracting from. So we needed to borrow 1 from the 6, bringing over 12/12, so 17/12 minus 11/12, and we should receive the answer of 2 1/2. That is all that the lesson is. The big ideas that you need to remember is make sure you have a common denominator. You may need to get equivalent fractions. You also need to make sure bigger bottom, borrow from the whole number, and always subtract the fraction first and then the whole number. Those are a few steps that are going to be helpful to you as you are working on your math journal pages. Good luck as you get started.